Try to look into the question beta. It says consider the following regression model. Price is equal to beta naught plus beta 1 SS plus U. You're given this model and it says that T values are given to you and the sample size is 88. You're also given SSR UR is this value. So just think about SSR ki jagah pe, consider it as residual sum of square. Right, I am not taking this as sum of square of regression, nahi le rahe hain. I will consider this as residual sum of square or sum of square of residuals. Isko maan ke I will use it like that. You're given that R square is equal to 0.82. It says how will you test that beta 1 is 1 and beta naught is 0 if you are given that SSR in the restricted model. So residual sum of square of the restricted model is given to you as 20944.8.99. Okay. Now try to understand that here I am taking that my null hypothesis is whatever restriction is given to me, that beta naught is equal to 1 and beta 1 is equal to, beta naught is equal to 0 and beta 1 is equal to 1. Ye mera null hypothesis hai. And my alternative is that either one of the null hypothesis condition is not satisfied. It is very simple. I am just going to go ahead and calculate F value. So F test use karte hue, I can just say that F will be SSR minus SSUR divided by M divided by SSUR upon N minus K. Beta M is the number of restrictions that you put. So in this case, I am putting two restrictions, one on beta naught and one on beta 1. K is the number of parameters and N is the sample size. So if I just go ahead and I put it, this is going to be SSR, SSUR, M. Niche denominator mein SSUR and N minus K. Okay, I have just plugged in the values. When I will plug in the values, I am getting the F calculated as 11.371. And I am getting from the table that F tabular is 4.98. So clearly F calculated is more than F tabular. So I will go ahead and reject null in favor of alternative. I will reject null in favor of alternative. So this null hypothesis is not true, right? So this is how you can go ahead and use the restricted unrestricted model. Now, suppose the question says that model becomes this model. So you have more variables, you have SS, you have lot size, you have square feet, and you have number of bedrooms. And you're given that the R square of this big model. So I will consider this big model to be my unrestricted model. Because it's a big model. The bigger model is always considered to be unrestricted model. So now it says that the R square of this model is 0.829. It says test at 1% level of significance that all partial slope coefficients are jointly 0. So because I am doing a joint test in this case, what I will go ahead and do, beta, I will put my null hypothesis that all betas are jointly 0. And I will put an alternative hypothesis that at least one of them is non-zero. I will go ahead and I will do an F test. While doing this F test again, this is going to be R square upon the number of restrictions M upon 1 minus R square upon N minus K. Upon N minus K. Now, try to understand here I am not taking anything from the restricted model. Why, beta? Because in the restricted model, अगर मैं restricted model की बात करूं, तो restricted model में तो सारे betas ही 0 हो जाएंगे. This will also be 0, 0, 0. So I will not be left up with any model. So actually in this case, the R square of my restricted model, is actually 0. So I am only left up with R square of unrestricted model, and that is what I am working with. Is that making some sense? So I'm working only with R square of unrestricted model because restricted model mein all parameters would be 0 and therefore my R square of the restricted model will also be 0. A bit of attention. Suppose your null that you had to test was only this beta. That beta 3 equal to beta 4 equal to 0. Suppose ye test karna hota. It means that you were going ahead and testing that beta 3 and beta 4 are 0. Inse related, there is no test. right? So if this would have been the case, agar aisa koi case hota, then this formula would not have been a valid formula. Then in that case, your formula would have been r square unrestricted minus r square restricted divided by m upon 1 minus r square unrestricted divided by n minus k. So please try to understand कि had it been the case, suppose ऐसा कोई case होता that I would not have put restriction on all betas, then there would have been existence of r square restricted. समझ रहे हो बात को? मतलब मेरा जो restricted model होता, it would have been beta 1 plus beta 2 x2y plus beta 3 x3y. और अनरिस्ट्रिक्टेड मॉडल वही होता है y इक्वल टू बीटा 1 प्लस बीटा 2 x2y प्लस बीटा 3 x3y प्लस बीटा 4 x4y प्लस बीटा 5 x5y प्लस ui. तो समझो अभी इस मॉडल में भी these two remaining x's they are explaining some variation in y. तो यहां पर कोई r स्क्वायर निकल के आता, राइट, एंड यहां पर कोई r स्क्वायर निकल के आता अनरिस्ट्रिक्टेड. So I would have used this formula. But in this particular question, since I am putting beta 1 equal to beta 2 equal to beta 3 equal to beta 4 equal to 0, I am checking for all partial coefficient. तो यहाँ पे ये जो restricted वाला r square it became 0. There is no parameter left that can explain why. तो because this became 0, तो यहाँ से ये वाला जो component है restricted वाला, it just vanished. It just vanished. Are you understanding this? Therefore, it turns out to be this formula कि जिसमें हम सिर्फ unrestricted का value डाल रहे हैं. Okay, so my r square of unrestricted is 0.829 divided by number of restrictions. I am putting restriction on 4 parameter upon 1 minus 0.829 n minus k. There are 5 parameters. K is 5, n is 88. So when you will be solving this, you will be getting approximately 100.60. Again, आपका जो f का टेबल का वैल्यू है, right, you have to check for 4,83. It is approximately between 4 and 5. So it is very, very small. So your f tabular is very less. F calculated is more. So since calculated is more than tabular, you can go ahead and you can reject null in favor of alternative. You can reject null in favor of alternative. Is this question clear? Okay, beta. Thank you.